Welcome back to the course Corrosion. Today we are going to have our lecture number 23. So, in last lecture we started discussing discussing on nickel H2O system, and then we could draw a pourbaix diagram involving nickel, nickel plus plus and Ni-H2O, and the diagram looked like. So, this is pH axis, this is E in volt unit, this region was nickel, this was nickel plus plus, and this region was Ni-H2O, where if we extend this line if we extend, the point would be 0.11 volt, and this was minus 250 volt, and this pH was 6.09. And we could also see why different regions, how can we make sure that this region belongs to nickel, this region belongs to Ni-H2O, and this region belongs to Ni plus plus. And this also talks about the stability of those phases in those regions in that E versus pH diagram. Moreover, each line indicates the equilibrium between Ni plus plus. For example, this line indicates Ni plus plus and Ni, this line indicates Ni and Ni-H2O, and this line indicates Ni plus plus and Ni-H2O. Moreover, we could also see that some lines are potential independent. For example, this line belongs to potential independent. Then we have one line which is parallel to the pH axis, that means it becomes potential pH independent, but potential dependent. As we have seen that this was drawn as a when nickel ion concentration was 1, this is also belong to Ni plus plus activity equal to 1, then only we could get 0.25 volt, and we could see that if we change the activity of nickel plus plus from 1 to 10 to the minus 1, 10 to the minus 2 like that. So, this line would go down. And interestingly, another important aspect is when we draw these lines according to the reactions what we have stated earlier, we have to fix a nickel ion concentration. Now, if we fix this activity to be 1, then for this line we have to also see the activity of nickel ion concentration should be 1. Now, if we change it to 10 to the minus 6, then this line also needs to be changed to 10 to the minus 6. So, it will be valid for a particular nickel ion concentration. So, this has to be fixed first, and then we need to draw all 3 lines. Now, here if we could see that if we put it in a red color, let us say, let me choose a color, let us say this red color. If we choose that color, so this region I could see nickel plus plus, we can get nickel plus plus if we remain any potential and voltage potential and pH coordinate in this particular section, this particular section covered by this particular boundary. Okay. We would at any coordinates, for example, any coordinate Ni plus plus, and Ni plus plus formation is nothing but corrosion. That means ions, if we get ions of that particular metal, then it is actually dissolving in the solution, water based solution, because it is containing H2O, and that means corrosion. Now, if we consider a boundary, let us say if we have this boundary, there we get nickel, and as per our convention in this region we have least presence of Ni plus plus. that means nickel remains as nickel. So, we call this particular zone as immune zone. And now, the earlier zone we used to call it corrosion zone. Now, there is one more zone which is covered by this zone, where we have NiO, and interestingly we had a problem where we tried to see what is basically the tendency of nickel to get corroded in the water system. There we considered NiOH, but here it is NiO. Now, interestingly NiO, if we take NiO and H2O, NiO plus H2O equal to NiOH whole 2. This also settles down, this also settles down, because they have very low solubility product. Now, when it settles down, that time if it settles down on the nickel substrate, then we have a covering of the nickel surface. For the time being, let us put in this fashion, that if we have a nickel substrate, on that substrate we have this particular phase formation or this particular phase formation, we get a covering of that particular nickel surface, and then the nickel surface exposed to the water system, water or electrolyte, will be limited. So, the corrosion tendency of nickel will be sluggish. Though nickel corrosion is taking place depending on the solubility of nickel plus ion and 2OH minus ion. So, depending on that, the solubility will decide how much nickel plus ion would exist in the solution, but that solubility would be so low. So, the nickel ion presence would be so low. So, that time we call it as passivation. So, we call it passivation. So, this zone we call it passive zone. So, this is immune and this zone is corrosion. So, we have 3 zones specified according to the calculations what we have. In this zone we have immune, that means nickel remains as nickel, no corrosion would take place. In this zone we have that means we could say from this diagram that the corrosion of nickel would be a spontaneous process, that means more and more nickel ion would form. And here NiO or NiOH, when it forms, that time they try to make a deposit on the nickel substrate, and the solubility of that particular deposit will decide the nickel ion dissolution rate, nickel dissolution rate, and that dissolution rate would be much lower than the dissolution rate what we can experience in this particular zone. So, we call it a passive zone. So, we decide 3 zones. Immune, corrosion and passive. In fact, we can have such diagrams for many other metals. And coming to this particular phase, since we have done the calculation on the basis of chemical potential of NiO, we can have also the same plot if we consider NiOH. So, that time we have to take 2 more equations. That time we will not consider NiO formation. Ni plus 2H2O equal to NiOH whole 2 plus 2H plus 2E, one reaction. And if we do the calculation, we would see that the calculation would generate the same line what we see here. The same line, it will generate the same line if we fix the concentration of nickel ion. Now, here the nickel ion is not coming into picture. So, only thing is it will be decided by potential, which will be E0 plus RT 2F ln ox by red. So, this is activity of ox, activity of red, and here ox is nothing but NiOH whole 2 activity and activity of H plus square, and this one would be equal to activity of Ni, activity of H2O square. And if you do the same calculations, because if you take the chemical potential value of NiOH whole 2, which is nothing but minus 452,694 joule per mole, you will generate the same equation what we had for this reaction. What we had for this reaction. So, here we had, if we go back, you will see that this value would be 0.11 minus 0.0591 pH. Here also you will get the same value. Let us do that calculation. So, that time delta Z0 would be mu 0, because we have to consider this way, because we have to write ox plus E equal to red, mu 0 Ni plus 2 mu 0 H2O minus mu 0 NiOH whole 2 minus mu 0 H plus, and 2 electrons are involved. So, this is 0, this is minus 2 into 236,964.2, this will become plus 452,694, this is going to be minus so E0 would be equal to, so here this is minus 21234.4, N is equal to 2 and F equal to 96500 and with a minus sign. So, this becomes 0.11 volt. So, you for this reaction you get E0 like this, and E would become 0.11 minus, if you do the simplification, this goes to 1, this goes to 1, this goes to 1. So, you are left with this quantity. So, these two will get cancelled. So, finally, you would get the same pH, same equation. So, these two are getting the same equation. So, that means this line would be similar to NiOH whole 2 if we form NiOH whole 2 instead of NiO. And if you want to do calculation for the vertical line, so if you try to see the vertical line also, this is NiOH whole 2 and Ni, this line gives the E equal to 0.11 minus 0.0591 pH, and this line would be same as for this reaction. So, if you try to see the vertical line, so the new reaction would be Ni plus 2H2O equal to NiOH whole 2 plus 2H plus, it will give you the same equations. Let us get back to the equation. You will get the same equation like this, minus 2 pH plus log A Ni plus plus. You will get the same equation what we gotten for this reaction. For this reaction we got the same equation. I want you to try it out from the K. So, you have to find out K value. So, the log K equal to 0 delta Z0 by 2.303 into R into T. So, if you follow that and you have to find out delta Z0 for this reaction. So, delta D0 you find out from mu 0 NiOH whole 2 plus 2 mu 0 H plus minus mu 0 Ni plus plus minus 2 mu 0 H2O, you would get the same equation. So, that means whether you write NiO or NiOH, these lines would be same, because provided you are fixing the Ni plus plus ion concentration, you have to fix that. So, that is what you are getting. Main crux is you are trying to plot the corrosion zone, immunity zone and passive zone, but this pourbaix diagram is not complete if you do not put the equations or the reactions which involve no metals rather than oxygen, dissolved oxygen, hydrogen evolution, hydrogen H2, H plus and OH minus, of course, there will be water. So, I mean to say that this particular phase, this diagram, this E versus pH diagram, this should be complete once we include water reaction involving O2, H2, H plus, OH minus and H2O. So, let us do that. In fact, we have seen before, if you see the earlier lectures, we have done it. Now, we will just mention those equations and then accordingly we try to plot them. Now, if we write down those equations, first is acidic and then neutral or basic. So, this is pH less than 7 and here pH greater than equal to 7. So, there are two types of reactions. One is, and in that two types we have two reactions each. One is H plus plus 2E equal to H2, where the equation would be minus 0.059 pH, where E0 equal to 0, 2 O2 plus 4H plus plus 4E equal to 2H2O, and here you see that only H plus ions are involved. So, there E equal to 1.227 minus 0.059 pH, and on the other side we have 2H2O plus 2E equal to H2 plus 2OH minus, and for this E equal to minus 0.827 minus plus 0.059 POH. Why this term is coming for this reaction? If you do the calculation, delta Z0 would be mu 0 H2 plus 2 mu 0 OH minus minus 2 mu 0 H2O, and then here 2 electrons are involved. So, E0 would be delta Z0 minus 2 into 96500. If you do that calculation, because already you know the values of this, you just go back earlier lectures and then find out what are the values. So, let me iterate the same value once again. So, mu 0 OH minus equal to minus 147.1 joule, and mu 0 H2O equal to minus 2,36964.2 joule per mole, and of course, this quantity is 0 and you get minus 0.827. Now, interestingly here it is POH, because E equal to E0 plus 0.0591 by 2, and then activity of that log H2O, if we put it in concentration term, pH2 and OH minus whole 2. So, this is maintained at 1 atmosphere. The pressure of hydrogen gas is 1 atmosphere. This is 1, it is a pure substance, and so it becomes E equal to E0 plus 0.59 minus log of OH minus, this is nothing but E0 plus 0.59 POH, where POH equal to minus log of OH minus ion. Then if you do the simplification, then you would get E equal to E0 minus 0.0591 14 minus pH. So, where pH plus POH equal to 14. So, E equal to 0.827 minus, and sorry, this was plus, this should be plus because plus 0.0591 POH. So, POH equal to 14 minus pH. So, that is what you have put here. This becomes plus 0.0591 into 14 minus 0.0591 pH. You will see that these two quantities would could cancel. So, it becomes 0.0591 pH. So, now this acidic side, basic side, this is the basic side where pH equal to greater than 7, but on the basic acid side, this is the basic and neutral side, less than 7. For the first reaction, we had the same equation. So, that means they will be lying on the same line, but one starts from 7 on the right side in the pH axis, this reaction would start below 7 pH, and this reaction come involving H2O, this reaction would start when pH is equal to or greater than 7. Now, we had another reaction which is O2 plus 4H plus 4E equal to 2H2O. There the equation 1.227 minus 0.0591 pH, and here this side also we had another reaction involving oxygen plus 2H2O plus 4E equal to 4OH minus. In this case, the equation would become E0 minus plus 0.0591 POH. If you follow the same philosophy what we have done for this equation, then you convert this particular value would be 0.401 and then 0.0591 into 14 minus 0.0591 pH. So, if you add them, you would get the value which is 227 roughly minus 0.0591 pH. So, you have the same equation what we had for the acidic reactions. Now, if we would like to plot all those two reactions, so in this pourbaix diagram E versus pH, this value is 0 and then up to 7 pH, we have H2, and then if we extend it, that time it will be 2H2O plus 2 equal to H2 plus OH minus 2. Similarly, if we consider this reaction, this is 7 pH, they will be parallel because both the cases the slope is 0.0591. So, 1.227 volt, and then on the right side this would be the equation for this would be O2 plus 2H2O plus 4E equal to OH 4OH minus, and on this side it will be H2O. Now, these particular 4 lines are to be clubbed with the nickel pourbaix diagram, nickel those lines, then it will be a